Welcome to clickmeproject.com. Now we are going to see about an integrated linear programming receiver for LDPC coded MIMO-OFDM signals. Describing about this process, it is obvious that it deals with MIMO-OFDM signals, a novel approach that can jointly achieve detection and decoding of LDPC coded MIMO-OFDM signal are presented. When LDPC codes are applied within MIMO-OFDM, an ideal receiver should apply joint maximum likelihood detection and decoding principle. When LDPC codes are long enough, receiver is highly complex and impractical to implement. Decoders can be effectively done in its low complexity and good decoding performance. In that case, with the help of this method, the performance gain is achieved effectively. Even if there is any complexity, the cost will be moderate. This is the flow of this process. The first block indicates about the transmitted MIMO-OFDM signal. It mainly deals with the transmission side of this LDPC coded. That is, an LDPC coded MIMO-OFDM transmission is considered with NT number of transmitter antennas and NR number of receive antennas and N number of subcarriers. Transmission occurs as spatial multiplexing. Information is encoded with the help of LDPC encoder and it is modulated with the help of QAM. Signal is obtained with the help of IFFT decoding, that is inverse Fourier transform. The second block deals about the error correction codes. Here, what we are going to do is the node sets are partitioned into two disjoint node subsets. The low complexity decoders are used to get efficient output of LDPC codes. In order to perform effectively, the log likelihood ratio and sum product algorithm is used. Here, we use fast Fourier transform since it is at the receiver side. So, initially there are two types of error correction codes. The first is backward and the second is forward. The third block denotes about the turbo detection, that is, equalization and detection of MIMO-OFDM signal is done in complex area, while for LDPC it occurs in binary field. MIMO turbo equalization is performed here. The receiver has soft input, soft output MIMO detection and log likelihood ratio as well as sum and product algorithm decoder is used. Here we implement MAP detector, that is maximum A posterior rate. Detection of received signal can be carried out independently by considering perfect CSI, that is channel state information. Our fourth block indicates about the joint receiver. Here, a specific objective function is developed for LDPC codes. Linear programming detector is formulated here. If affine mapping occurs, LP1 logarithm is used. Here, we also use QPSK as well as QAM modulation techniques. For LP2 algorithm is implemented as a new joint detector for LDPC coded MIMO-OFDM. For non-affine mapping, LP2 algorithm can be used. The final block says about the main concept of this paper, that is complexity reduction. Here, the total number of constraints is reduced in order to decrease its complexity in computational manner. ALP method is applied in which only useful constraints are added. Both QAM and QPSK are tested with different transmit antennas. Turbo iterations is valued for good convergence. This is the MATLAB command window where the code for this process is present, and these are the programs. This is the main file, while these two are the subfunction and it will be called inside the main. So now we are going to run this main file. Now I am going to click about this main file and Now we are going to select Run File option. Now the process is doing on. Here we are achieved our results, that is we obtain it as 3 figures. The first figure deals about the QPSK modulation, that is in MIMO-OFDM what will happen if both backward and forward error ratio is found, and we are going to find the bit error probability. We are going to measure the ratio between the bit backward, forward as well as the bit error probability. When regarding about the figure 2, it deals with about the QAM modulation. Since in our paper they have used both QPSK and QAM, we have also implemented these two modulation techniques. In figure 2, in the same manner we have compared the backward as well as forward error ratio with bit error probability. While in the case of figure 3, we obtained the result for QPSK modulation. Initially, in figure 1, we have done it for MIMO-OFDM, how the QPSK modulation occurs. But in figure 3, we formulate about the bit error probability ratio and compared it with backward error ratio as well as forward error ratio. Thus, we can conclude that our process has reduced the complexity when compared to these both. Thank you.